Hello everyone, welcome back. In this video we'll be taking a look at the squeeze theorem. So the squeeze theorem, it says that if a sequence is sandwiched between two other sequences xn and zn, such that if xn is less than or equal to yn and yn is less than or equal to zn, and if both the sequences xn and zn have the same limit L, then the limit of yn is of course L. So let's do the proof of this theorem. So we know that the limit of xn and limit of zn is equal to L. That just means for all epsilon greater than 0, there exists n1 such that xn minus L is less than epsilon for all n greater than n1. And then for all epsilon greater than 0, there exists n2 such that Zn minus L is less than epsilon for all n greater than n2. We know this is true because we're told that, and we need to show that for all epsilon greater than 0, there exists an n such that yn minus L is less than epsilon for all n greater than n. So xn minus L less than epsilon can be rewritten as, is the same as writing it as xn minus L epsilon minus epsilon, which is the same as xn less than L plus epsilon L minus epsilon. Remember that this is the tube we talk about always, and this can also be written as yn less than L plus epsilon L minus epsilon. And we need to show that yn is less than L plus epsilon L minus epsilon. So, but we know yn is less than or equal to zn, and we know, sorry, this should be zn right here, and we know zn is less than L plus epsilon, and we know yn is greater than or equal to xn. When we know xn is greater than L minus epsilon, I'm getting this statement from here and here. And now I'm just going to focus on this and this to write it this way: yn is less than L plus epsilon and L minus epsilon, which is what we needed to show, because this is exactly the same as yn minus L being less than epsilon, and we're done with the proof. So that's basically what the squeeze theorem tells us. So let's take a look at an example involving the squeeze theorem. So we are supposed to find the limit of this sequence cos of 2n squared plus 1 over root n. Well, this looks like a pretty complicated one, but with the squeeze theorem it turns out to be pretty easy. Now remember that the cos theta is bounded by 1 and minus 1, because if you look at the graph of cos, it goes somewhere like this, and this is 1 and this is minus 1. It's always, cos is always between 1 and minus 1. So we can rewrite this complicated one as being this is less than 1 over root n and is greater than minus 1 over root n. So now if we find the limits of 1 over root n and minus 1 over root n, and they're the same, then of course the limit of the middle one will be the same as the limit of 1 over root n and minus 1 over root n, and we get that the limit as n approaches infinity of 1 over root n is equal to 0, as we have proved in previous videos, and the limit of n approaches infinity of minus 1 over root n is also equal to 0. Since the 1 over root n tends to 0 and minus 1 over root n tends to 0, cos of 2n squared plus 1, which is sandwiched by both of these ones, also tends to 0, and we're done with with that example. So hope you guys have enjoyed this video. See you next